Good old super glue. 70% of the time, it never lets me down. Hello Internet, my name is Quinn and this is Blondihacks. Today I'm going to make the cylinder heads for my big steam engine project, and I'm also going to do the alignment of all of the bottom end motion work. It's a very important job and we're going to do both of those right now. First order of the day here is to get the bottom end aligned. You can see that everything's all loosey-goosey here, and that might seem like a weakness in this design. Why would these all be separate parts? But I think it's actually designed for manufacture. Because, for example, the crosshead bore being round means the bottom end can rotate and the engine will still run. So this allows you to adjust for any manufacturing defects in all the parts of the motion work. However, getting it all aligned does take some effort. So I'm going to start by taking it all apart here and putting the base onto the frame. The frame really can go anywhere because all the other parts can be adjusted relative to it. So I just centered it on the base, transfer punched one hole, then I'll deepen that center punch, and then I can take it over to the mill and drill and tap that hole. I just line the center drill up on that punch mark there by eye, center drill that, and drill that through tapping size. I'm just tapping these holes all the way through the top shell of the casting here. Then tap that through. I'm going to be test fitting all this with the bolts that came in the kit, but they're slot-headed screws, which I don't like very much, so I'll be replacing those with studs and nuts probably. Remember, this is originally a farm engine from 1895, so it probably came with square-headed bolts back in the day, so I might do something like that for authenticity. With one bolt in place, I can verify the alignment there. Everything looks good, so then I can transfer punch the other three holes. I don't like to do all four transfer punches at once because the part tends to move while you do that. Putting in one bolt and then bolting it down and then doing the other three seems to give me much better results. Now with the frame secure, I want to make sure that I can get it back into this position when I take the engine apart, because you always have to take engines apart. So I've got this crazy setup over on the drill press that's going to allow me to drill upside down here into the bottom of the base. I want to install alignment pins in the feet of this assembly here. And I can't do this right side up because I don't have drills anywhere close to long enough to clear the frame there, so I got to do it upside down, and this is the only way I could think of to do it on the machinery that I have. So it's not the most rigid setup, but I think it is going to work. I've got punch marks in there where I want these alignment pins to go, so I'll line up a center drill on those marks there, lock everything down, and then go ahead and center drill. I'm drilling the pilot drill size for a reamer. These are blind holes, so I've got the depth stop set on my drill press. Got to make sure to clean the hole out thoroughly there so that the reamer doesn't get jammed up, and then I ream that down to the same depth. I prepared the pins ahead of time. They're just little pieces of 01 tool steel drill rod. They're precision ground, and I just faced the ends on the lathe so I can test fit that in there. And that looks good. I'll set the length later. I just need to get those pins in there so that everything is held in alignment while the assembly is all bolted together. So there's the first pin there, as you can see. And that worked out well. Now I can reverse the structure here and do the same thing on the other side. I should point out that these alignment pins are actually not in the drawings. The drawings just call for everything to be bolted together. But honestly, I kind of think that's horsey talk, because without alignment pins, once you get the engine running, you could never take it apart again. You'd never get all of these parts back in the right place again. So I'm not really sure how the factory intended you to do that. In any case, the pins get Loctited into the top half there, so they're captive in one of the two components. And now you see how the two parts will forever be able to slide back together into the same alignment. I should say those pins are also off-center. Both of them are shifted the same side of center so that the frame can only go back on one way. Everything will only align the correct way. Now I got to get everything else aligned to the frame, so I'll bring in the crankshaft and the main bearings here. Then I can bring the frame in, and basically I need some way to kind of hold the motion work in place temporarily while I locate the best position for it. Now I tried a lot of things, and what I landed on was these padded carpenter's clamps. I know it looks like you can clamp on the flanges at the base of the main bearings there, but trust me, you can't. It's very deceptive. They're smaller than they look, and the angle is wrong for the hollow base underneath. There's just no way to clamp them. So I'm clamping fairly lightly here because I don't want to compress that bearing, which would distort things. Because the goal here is to get the motion work running smoothly while it's in a clamped position. So I'm fiddling with things, eliminating tight spots, adjusting clearances, rotating the crankshaft a little bit if needed, sliding the main bearings in and out, sliding them laterally, etc. until I get it to where it's running well and is in a clamped position. Then I transfer punch one hole on one of the bearings. I go and I drill and tap that on the mill. I put the whole assembly back together, I put that one bolt in, and then do the fiddling again to get it aligned again, make it run smooth. Then I transfer punch a second bolt. And once I've got 2 bolts in each bearing that way, then I go ahead and transfer punch all the rest. And that seems to have done the trick. It's running smoothly now with all 8 bolts in the main bearings there. But once again, I want alignment pins in there because I don't ever want to do this again. It would be nearly impossible to drill these from below and get them in the right place, so instead I'm removing the crankshaft and the bearing caps there, and I'm setting it up in the mill like this, and I drilled and reamed these alignment holes from above. It just means the alignment pins will be visible, but that's okay. It's all going to be painted anyway. Once again, I made a little alignment pins there from some drill rod. I did one of those on each side of each bearing, and I'm punching identifying marks on all the mating surfaces here so everything goes back into the same place in the same direction each time. And there we go with alignment pins and everything, and the main bearings holding the caps aligned. The entire engine will now come apart and go back together to probably within 1,000th, maybe 2, anytime I want to. Once again, those alignment pins are not specified in the drawing, but I think you are crazy to not do them, so that was absolutely worth the effort because now I can trust that this engine is going to run smoothly like this every time. Onto the cylinder heads now. We've got 2 castings, the outboard head here with the little ring on it, and the inboard head on the left. Now I've got some scraps of aluminum here as well because there's going to be some tricky fixturing involved. Anytime you've got thin castings with no easy way to hang on to them, you know there's going to be some fun involved. As usual, I'm going to start by fettling the castings here. I always make a plan for how I'm going to fixture before I do this, however, because sometimes those sprues are the key to holding on to a tricky casting in the machine tools. In this case, though, they're going to be in the way. I'm also sanding off the casting scale there, as I've been prone to doing lately. It really does seem to make the machining go easier. Starting with that small scrap of aluminum now, I'm going to make a special widget for the tailstock. Normally with a flat casting, like with the outboard cylinder head, I would use a superglue mandrel to hold that. However, this is not like a typical model engine. This is a big heavy cast iron part, and I kind of don't trust superglue to do that alone. So I'm going to use an old school technique called pressure turning. What I'm making here is a pressure pad for the tailstock that's going to provide the support that the part is going to need. I begin by turning down an arbor here that can go into my Jacobs chuck. My chuck has a limit of 1/2 inch, so I'm turning a 1/2 inch boss on this. Next goes a very generous center. I think this is a number 4 center drill, which is pretty big by my standards, because that's going to give it lots of support on the tailstock live center. Then of course we chamfer that, because chamfers are what separate us from the animals. Now I can flip it around and finish it up from this side. Here we have what is probably the worst bandsaw cut in the history of Drunken Monkey bandsaw cuts, so it'll take quite a bit of work to face that down, but face it down we will. Now I'm going to turn down the OD. The diameter of this can be pretty arbitrary for a pressure pad, doesn't matter a whole lot, but I'm specifically making it smaller than the registration boss feature that needs to be on the cylinder heads. And that will enable us to rough in that feature with the pressure pad in place, as you'll see. Next, a little scrap of emery paper. This happens to be 320, but probably anything would work. And some 3M Super 77 spray adhesive. Definitely aim away from face with this stuff. It turns everything in a 5-foot radius to a gooey mess. Once that glue is set, then I can just cut around it here with a craft knife and very satisfyingly pull that excess off of there. And now we've got a nice grippy little pressure pad that will help hold things in place on the lathe. To the other scrap of aluminum, I'm going to make the mandrel to hold the outboard cylinder head, which is the trickier of the two, so I'm starting with that one. This also has a giant mess of detritus on the front of it to face off. I think this was trepanning practice, maybe? I faced this all the way down. There's traces of a groove left when I was done here, but that's fine. A little bit of texture will actually help me with the super glue. Now I'm going to take advantage of this decorative ring here on the back. I'm going to use it for alignment, for concentricity, and also as extra surface area for the glue. So I'm going to cut a groove in the face here that is going to match the OD of that decorative ring. I'm not going to try to match the OD and the ID because that would be extremely difficult to get right. However, just matching the OD is pretty straightforward. I cut this little by little on diameter and depth until I had what seemed to be a good fit on that ring. Just kind of did this by feel. It's hard to know when it's perfect. I am measuring at the root of the taper there to try and match the base of the tapered ring, but with castings that's always a little bit of a fool's errand anyway. That feels like a good fit though, so I think I'll go with that. So I'll get the super glue on all of the relevant surfaces here. I'm putting it on every surface that might touch the casting, even though I don't know for sure all those surfaces are touching the casting, but I want to maximize my chances of a successful glue here. Hold that on there, and then I'm going to bring in the pressure pad there, and I'm going to use it to hold the part in place while the glue sets. Put some solid pressure on it with the quill there, and then give it a little spin to kind of self-center things, and then leave that for the glue to cure. Once that's cured, now I feel comfortable turning it, so away we go. These are fairly large diameter, so on the OD here of the cast iron, the cutting forces are pretty high, and I really wasn't confident that super glue alone was going to do it, but this is working extremely well. It's worth noting that machinists have been using pressure turning to turn thin disc-shaped parts like this for 100 years before super glue was invented, so the super glue in principle isn't even necessary, but the two of them together should certainly be sufficient. So I'm turning this down to the OD specified in the drawing. This is not a very critical dimension, so of course I nailed it because I always nail the non-critical ones. Now I can face the inside here. Now this is the underside of the head where it's going to fit into the cylinder, and the job here is to get the overall part to the correct thickness while also roughing in the boss there. So I'm staying a bit oversized on that boss in the middle there because the dimension on that boss is extremely critical. So I'm just worrying about one dimension at a time here, getting the thickness correct overall, and stopping in a place that I know is well short of the final dimension for that boss. And as you can see there, the pressure turning pad is smaller than the boss is going to be, so it's not in the way for any of this. Then I turn the OD of that boss just to clean it up. It's still oversized at this point, but I want a decent starting point for my measurements to begin here. The trick with this boss is that it's too shallow to reach with my micrometer, so I need to use the guessometers here, which really aren't good enough for a fit as close as I need here. So I'm aiming for a thou or two oversize with the guessometers, and then I'm going to finish up by test fitting. So I have to remove the pressure pad now and put my faith in the super glue. And what I'm doing is just taking very, very light cuts. I know I'm within a couple of thousandths here, so I'm taking like half thou cuts at a time, basically the lightest cut that I can confidently do on my cross-slide hand wheel, and then deburr after each of those to ensure a good test fit. And then I bring the cylinder in and test fit. And I just repeat, doing a very, very, very light cut, and then test fitting and another light cut. If you're doing like half thou passes at a time, then you know your final fit is going to be within half a thou, which is an excellent fit. So that's why this works. You could also try to do this with emery or a file, but because it's so shallow, I wasn't confident that I could do that without introducing taper to that shoulder. So that's why I'm doing it with the turning tool. I'm close now, so I'll do one more test fit. And yeah, I need to do one more cut, I think, maybe two. It's close, but we're not quite there. So I'll just remove this and do one more cut. And fun fact, that super glue gave out at one of the worst possible moments because I literally had like one more half thou cut I needed to do. And now I've lost my concentricity, so it's going to be tricky to get this back together again. So I reapplied the super glue, used the pressure pad to seat that while it cured again. And as you can see, of course, now there's all manner of run out there. I had no hope of ever getting it back into the same position that it was in. So instead, I'm going to bring in the forejaw and I'm going to dial in this mandrel once again and get it back to where it was. Dialing in the OD is easy, of course, because that's machined. Dialing in the face is a little trickier because I don't want to hammer on the front of it like I normally would because that might break the super glue loose. And I do need to dial it in, as you see here. So what I'm going to do instead is I've got some copper back there to protect the face of the chuck, and I've got a tapered punch there, and I just tap that punch in under the low side of the face there, and I can move it outwards, watching the indicator there. Pull that out and give it another spin and find the next low spot and so on, and I was able to dial it in within 1,000th there doing that. Then of course you check the OD again and that ran out a little bit. It's bound to have moved, and it did. So dial that back in, check the face again, and the face is still pretty good, so we're going to roll with that. It's never fun when you have to recover a setup like that, but just goes to show that you always can do it pretty much, so don't be afraid. That allowed me to take my last couple of very light finishing cuts and then do my final test fitting here. I needed to do this because I needed 2 more cuts off of this, but if I'd only needed, say, a couple of tenths, then I probably could have just finished it up with emery or a file in the 3-jaw setup that was running out, because for emery paper or a file, it doesn't have to be concentric because those follow the surface. And that is a very, very good fit on there. Then I can finish up by facing the boss here down to the correct thickness, which is fairly important because this boss impinges on the steam expansion area at the end of the piston, so this needs to be fairly accurate. And you can see I've got a board down there in case the part falls because I don't totally trust this super glue. And then I'll deburr that so that it fits nicely into the bore. And I figured I could just tap it off of there now that I'm done with the lathe work on this part. And of course, now it's the strongest super glue in the history of super glue. Well, off to the heat then to get it to break free. So I set it up like this and put the torch on the aluminum there. I like to do this upside down because then the part self-releases automatically when the heat is exactly correct. You don't have any risk of overheating it and warping anything then. All that nasty residue is easily removed with acetone, so no worries there. The inboard head is easier because it has a hole in the middle. Anytime a part has a hole in it, that's likely going to be your fixturing method. I'm going to start though by dialing in the disc casting here in the forejaw, just using that boss there. I mean, you know, if you can get it within 5,000ths, you're doing pretty good with a casting, so that will do nicely there, I think. I'll start by facing off the end of that boss, as is tradition. I'm not going to do really any machining work on the part here. I'm just creating the center bore here, which is going to be the reference for all the subsequent machining operations. Concentricity is important for all of the features on this part, so I want everything to be done in a single setup from a single reference. So I center drill, pilot drill, and ream this bore here all the way through the center. And a quick deburr there, that's looking good. Now I can pull it off and get to the real work. The tricky thing about the inboard head is that it has registration bosses on both sides, one for the crosshead bore and one for the piston bore. Those have to be as perfectly concentric as you can get them because they're going to control the concentricity of the piston and the piston rod running through the head. So, in order to get those as good as I can, I'm going to do both sides in one setup. To do that, I've got a scrap of steel here, and I'm going to turn a long mandrel that's going to let me access both sides of the part. I've got a left-hand turning tool there, and I'm marking how much room I'm going to need to the left of the part there. I need to know where the casting should sit on this mandrel. And then I'll turn down that mandrel, leaving a shoulder on the left side there, which is going to square it up and act as a grip. So I want that shoulder to be nice and clean and square there, so I'm facing that carefully. So that's a very close fit on there. And I don't know if it's obvious on camera, but the outboard end of that is also turned down another 5,000ths. There's a very subtle shoulder there. And that's so that I can thread this nicely, but then the registration section there is still perfectly sized for the bore here. Note that the mandrel is a smaller diameter than the boss there, so I can still access the boss as well for machining that. Then a nut and a copper washer on the other side to give me a good grip. I've got the tailstock in the end for support, and we should be good to go. Hopefully that single nut will be sufficient grip on this part to withstand the machining forces. I'll start with the OD once again. This is the easy and fun part. Well, it's all fun, that's why we're here. With that on dimension, I'm going to face it down as close as I can to that nut. Of course, there's a little bit of material under the nut that I can't reach here, but that's okay. We'll deal with that later. Then I rough in the registration boss on this side exactly as I did on the outboard head. Same deal, I just face down the material to the right thickness and then rough in that boss and then do light cuts and test fits until the cylinder is a really good fit on there. Now in with the left-hand tool, and I need to do similar work on the other side. I'll start by facing to clean up this side, and I'm going to turn that boss there to clean that up as well. And now once again I can turn the boss on this side. Same process here, I'm facing the large diameter down to the correct thickness, leaving the boss oversized, and then I finish up the boss. Now the trick here is I can't test fit it because this is on the inside of the mandrel and this has to go on the crosshead bore, which is part of the giant frame. So instead I'm getting it close and I'll check it here in a moment. But I want to clean up the end of that boss while I'm here. You see there's a bit of rough casting edge left there. The casting was actually too small to clean all of that up and still leave the boss the correct dimension. So I cleaned it up as lightly as I could and then I took care of that corner with a chamfer tool, which will look nice. It's all going to be inside the crosshead bore, you'll never see it anyway. I break all the sharp edges and we're very close to being finished. Take the part off now and go over and test fit it on the crosshead bore, and as predicted it doesn't quite fit, it's a touch oversized, so I can put it back in the mandrel and take another light cut. This mandrel is repeatable and that's the great thing about it. I can put it back on there and it's perfectly concentric once again, take another light cut. Now we got our perfect fit. So now there's that little bit of rough cast area there in the middle to get rid of, so I'm going to set it up like this in the forejaw to face that off. I've got some copper shims there to protect the material, and I tapped it in square against the chuck jaws there, which I thought would be sufficient, but turns out it wasn't, as you'll see here in a moment. I dialed it in using a gauge pin in the middle there, but honestly this wasn't necessary because we're just facing it anyway. And then I took a skim cut there to match it up with the boss there. This is not critical. This area is just sitting in empty space inside the cylinder, but you can see that it doesn't quite line up there. And you saw the run out when the part was spinning there. It turns out that the boss on the far side of the part was actually touching the insides of the chuck jaws, which was preventing me from tapping it flush against the jaws, so the part wasn't sitting flat in the chuck. But that's okay, nobody will ever see it, and I won't tell anyone if you don't, Internet. One more important detail though, I need a thread in the middle of this boss here. For this I do need it to be dialed in extremely flat here and square, so I'm tapping it in nice and flush, checking it with the indicator. Once I've got that flat, then I can go back and dial in this boss here. Accuracy is important here, so I'm taking my time and going back and forth as needed to get that running really true. That looks really good, so now I can come in with the tapping drill size. The depth is important. So I've got a feeler gauge in there to find the end of the part, and I can drill that into specific depth. If you're wondering why didn't I do all this when I first created the boss, it's because this threaded hole goes most of the way through the part, and I wanted that small, smooth, reamed hole all the way through the part for good support and good repeatability on the mandrel. That's why I did this threaded hole at the end. Threads are not good for locating a part. They're only good for clamping things together. That thread is for the packing nut that's going to seal the bottom of the piston rod. Quick setup over on the mill now. I need the bolt pattern. So since this is the inboard head, it's got the weird non-standard bolt circle on it. For this I have this drilling template, which you've seen before, which makes quick work of that. The outboard head is trickier. For that I'm going to use that aluminum mandrel again, use it for support underneath the part. I'll clamp that in place. Now dialing it in is a little tricky. I can't use the coaxial indicator here, so I've got my DTI holder that I recently made in a video that you may have seen on the channel. This allows me to dial it in using only the 340 degrees or so that I have access to with the clamp in place. Once I've got it dialed in, then I can add a clamp, and now I can use the bolt circle function on the DRO to drill this bolt pattern. Well, that seemed to go well. It looks great from underneath. Flipping it over now though, I decided, yeah, those bolt holes really need spot faces, both for appearance and so that the nuts have somewhere nice to sit. I don't like fasteners on casting surfaces if I can help it. To hold it the other way then, I brought in my drilling fixture again, and I've got a small V-block. That's actually the bottom of my cross drilling fixture. I don't have room in the vise for a full V-block. I used the drilling fixture to register the boss there and get the part centered up, and then I was able to rotate it into position on the number 1 bolt hole. Quick check to make sure it lines up with the bolt pattern that the DRO says it should, and now I can clamp it down and come in and spot face these. If you're wondering why I didn't just set it up like this in the first place and drill it from above and spot face all in one setup, I am also wondering that, and I have no answer for you other than I just didn't think of it. Let's do an all-up test now, as the rocket scientists would say. The inboard head goes on top like so, and then the cylinder head goes on top of that, keeping everything concentric there because of those bosses, and then the outboard head goes above that, and it's really starting to look like a steam engine now. We're up to 18.5 inches now. I think that's as tall as it's going to get, but good grief, this thing is a beast. It's really hard to overstate how big and heavy this thing is. Well, there's the 2 cylinder heads all complete there. I'm very pleased with how those turned out. I think they're really nice, machiny looking parts. I love cylinder heads. They always have a really nice look to them on steam engines. That's it for this video. I hope you enjoyed watching me make these parts. Thank you so much for watching, and thanks so much to my patrons who make all of this possible. Thank a patron today if you haven't already. They're making all of this content happen. And I will see you next time.